Hello everyone, I am Sahana Kulkarni. Today we will discuss again the chapter Nuclei, the continued part in this session 4. So in this session first we will discuss regarding the nuclear force. So what is meant by nuclear force means already we know in a nucleus there are protons and the neutrons which are present, that is we can call it as nucleons. They are strongly bound with attractive forces and that is known as the nuclear force. So inside the nucleus the protons and neutrons they are strongly bound with each other, and with the help of that is nuclear force only they will bond with each other, that is called as the nuclear force. And next we will discuss regarding what are the characteristics of the nuclear force. The first one already we know, the nuclear force are the strongest force in the nature. In the first PUC we have discussed regarding this, that is the fundamental forces, the four fundamental forces we have discussed. In that the strong nuclear force and the weak nuclear force, it we come across with this. So the nuclear forces are the strongest force in the nature. That is, the nuclear force between the protons inside the nucleus, it is more than 100 times stronger than the electrostatic repulsive force between them. And similarly, the nuclear force between the two protons as well as the two neutrons, which is of the order of 10 to the power of 38 times stronger than the gravitational force. So we can say that the nuclear force are the strongest force in the nature. Similarly, the second point or the second characteristics, it is also come across with the first year, that is nuclear forces are the short range force. So each nucleons that will be comes under the influence of only those nucleons which are the immediate neighbor. So whenever the interaction will be taken place, that is the each nucleon that will be comes into the contact with the immediate neighbor of the neighbor of that nucleon or neighbor of that nucleons. So nuclear forces that will be appreciable only when the nucleons they will be separated by a certain distance, and that distance is of 2 Fermi, and it becomes negligible if it is beyond the distance of about 4 Fermi. So only if it is a distance between 2 to 4, then only the range will be calculated and the nuclear force will be the effective. But if that will be negligible, if it comes again, it is beyond to the 4 Fermi. So this is the second characteristic, that is nuclear force are a short range forces. Coming towards the next one, that is nuclear force are charge independent. So remember this, the nuclear forces are the charge independent, means the nuclear force that does not depend upon the charge of the interacting nucleons. Suppose if it is interacting with a proton, means it is not going to depend upon positively charged. If it is going to interact with a electron, means it is not going to depend upon negative, means it is totally charge independent. The nuclear force between the two proton as well as the two neutron and the proton and the neutron, that is found to be equal when they are separated by a very small distance. So it is not going to depend upon the charge. So the nuclear force is equal for proton as well as proton to proton, proton to neutron, and proton as well as the neutron. Coming towards the fourth characteristic, that is nuclear forces have a property of saturation. Saturation means the nuclear forces are the limited in range. So as a result, each nucleon that has to interact only with a limited number of the nucleons which are nearest to it. So because of this, the binding energy of a nucleus is directly proportional to the, or we can say it is proportional to the mass number. So it is nuclear force have a property of saturation. Then the nuclear forces are spin dependent. Again remember this point, the nuclear forces are the spin dependent. The force of attraction of two nucleons which are having the parallel spin. Parallel spin means the same spin is stronger than the force of attraction between the two nucleons which are having anti-parallel spin. So if it is a parallel spin is there, then the nuclear force is more, and if it is anti-parallel spin, the nuclear force is less. So nuclear force which is depend upon the spin. Then coming towards the next one, the nuclear forces are the exchange forces. So the nuclear forces are brought into existence due to the exchange of the particles. They are called as pi mesons. That is the pi mesons between them. The pi mesons are there. They are the elementary particles. So with the help of this, the exchange that will be takes place. There are three types of pi mesons are there. That is pi plus, pi minus, and pi raised to 0. Pi mesons, or also we can call it as it is pions. These are the elementary particles which are belonging to the group. They are called as mesons. And the charged pi mesons are pi plus and pi minus. They are having the mass of about 273 times more than that of the electron. And the neutral pi meson is pi raised to 0, which is having the mass 264 times of that of the electron. So according to the theory that will be put forward by H. Yukawa, who is a Japanese physicist, in 1935, there is a continuous exchange of pi mesons between the nucleons. So this results in exchange of force and keeps them bound together. A proton inside the nucleus that emits the pi plus meson and it become a neutron, and a neutron which absorbs the pi plus meson and it become a proton. So then again a neutron, if it emits the pi minus mesons and it becomes a proton, and a proton it absorbs the pi minus meson and it becomes a neutron. So like this way the exchange process will be taken place. And with the help of this exchange process, the attractive force that will be developed between the protons and the neutron, and the attractive force between proton and similarly neutron and neutron, that is developed due to the exchange of pi raised to 0 mesons, because it is a neutral. Pi raised to 0 is a neutral. So therefore the attractive force between proton and neutron develop because of exchange of pi raised to 0 mesons. And inside the nucleus, a proton and neutron keep on changing that each other. Proton and neutron keep on changing into each other. These pi plus, pi minus mesons, whatever it is there, that will be continuously goes on exchanging, or it will be goes on changing continuously in case of protons and the neutrons. So this is what the nuclear forces are, the exchange forces. Coming towards the next point, that is the nuclear forces have the repulsive core. Means at a very close distance, which is of the order of 0.5 Fermi of approach between the two nucleons, the nuclear force becomes a repulsive force. Hence, the two nucleons cannot approach each other too closer than this distance. So, you may ask whether the protons and neutrons, they are tightly bound with each other, and how the repulsive force. Yes, of course, but the separation between them, if it is less than 0.5 Fermi, then there will be a repulsive force will be taken place. So, the nuclear forces have the repulsive core at a certain distance. Then the last point or the last characteristic is the nuclear forces are non-central force. The force which is existing between the two nucleons does not act along the line joining their centers, but it depends on how the nuclear spins which are oriented relative to the line joining on the nucleus. Already we know the nuclear force which will depend upon the spins. Therefore here the force which is existing between the two nucleons, it does not depend upon the line joining their centers, but it only depend upon the nuclear spins or oriented relative to the line joining the nucleons. So these are the characteristics of the nuclear force. Next we will discuss the concept radioactivity. In 1896, Henry Becquerel, who discovered that uranium gave out some type of radiation that could affect the photographic plate which is covered by the black paper. And it was found that the radiation were highly penetrating and also ionizing the gas and caused the scintillation on the fluorescent screen. Similarly, in 1898, Madame Curie or Marie Curie, she also discovered a new element called radium which was many times more active in emitting the radiation than uranium. So, radioactivity means the phenomena of spontaneous disintegration. Spontaneous means continuously disintegration of a nuclei of heavy elements with the emission of certain radiation. That is called as the radioactivity. So certain elements, they will continually emit the radiations from themselves. So spontaneous disintegration of nuclei of heavy elements with the emission of certain radiations is taken place and is called as the radioactivity, and the elements which shows the radioactivity phenomena, they are called as radioactive elements. And the radioactivity, it is found in naturally occurring elements whose atomic number is 83 to 92. So in these atomic numbers, the radioactivity that is found in natural and is known as natural radioactivity, and the radiations which are emitted during the radioactivity, they are called as radioactive rays. And the radioactive rays which are emitted by naturally occurring radioactive substances or the elements, they are found to be three types, or the radioactive rays are three types. One is alpha rays, and another one is beta rays, and another one is the gamma rays. So now we will discuss how to identify these alpha and beta and gamma rays. So the types of radiation that can be demonstrated by the experiment, that is as shown in the figure. So just to observe the diagram here. In this case, a small quantity of radioactive substance which is placed at the bottom of the small hole which is made in the lead block. So just in figure, both the figures, the lead block is there, a small hole is there. So in that small hole, a radioactive substance which is placed here. Why we are using the lead here? Because the lead absorbs all the three types of radiations such as alpha, beta as well as the gamma radiation. So when these radiations which are subjected to the electric field, in figure A just to observe, so entire these radiations that will be subjected to the electric field, it is found that the some rays which are deflected towards the negative plate, and some rays which are deflected towards the positive plate, and some rays do not deflect at all, they will be remains as it is. Same thing that will be observed when the same lead block which will be affected or which will be connected with a magnetic field, or entirely it is kept in an uniform magnetic field. At that time, some rays which are deflected towards the left, some rays are deflected towards the right, and some rays do not deflect at all. So it is found that the some rays are deflected towards negative plate, some are at a positive plate, and some are do not deflect at all. So coming towards the conclusion here, the first one, the radiations which are deflected towards the negative plate in an electric field, or which are deflected left side in the magnetic field, they are called as positively charged particles and they are called as alpha rays. So they are called as the alpha rays. And similarly, second one, the radiations which are deflected towards the positive plate in the electric field or deflected to the right in the magnetic field are negatively charged and they are called as beta rays. Similarly, the radiation which are not at all deflected both in electric as well as magnetic field, they are called as the gamma rays. Once again, you can observe in the diagram. So alpha rays which are deflected towards the negative plate, therefore it is called as a positively charged particle. And similarly, beta rays which are deflected towards the positive plate, and hence it is called as a negatively charged particle. And the gamma rays, they are not at all deflected and it is called as in both the cases it is not at all deflected, therefore we can call it as it is an uncharged particle or uncharged ray. So coming towards the properties of these rays, so that is properties of radioactive rays. The first one is the alpha rays. First point, that is alpha rays are deflected both in electric as well as magnetic field, and the sense of deflection shows that the alpha rays are positively charged because it is deflected towards the negative plate, therefore we can say it is a positively charged particle. Similarly, alpha rays produces an intense ionization whenever they can pass through the gas, and the ionizing capacity is about 100 times more than that of beta and 10,000 times more than that of the gamma rays. So the ionization power is more here, or ionization capacity of alpha rays is more as compared to beta and the gamma rays. And alpha rays have a very small penetrating power in the matter here, but the penetrating power is less as compared to beta and the gamma rays. So alpha rays has a very small penetrating power. Similarly, alpha particles are emitted with a velocity of order of 10 to the power of 7 meter per second, and the mass of alpha particle is found to be 6.645 into 10 to the power of minus 27 kg, and the charge is found to be 3.2 into 10 to the power of minus 19 coulomb, which is same as the helium nucleus. Therefore, we can say the alpha particle or alpha ray is nothing but it is a helium nucleus, because it is identical to that. Coming towards the next properties, that is beta rays. The first one, the beta rays, which are deflected both in case of electric as well as magnetic field, and the sense of deflection shows that the beta rays are negatively charged particles. And beta rays produce ionization in gas through which they pass, and their ionization is 1 by 100th of the alpha rays, means the ionization power is less compared to the alpha ray, but the penetrating power is more. The beta rays have 100 times more penetrating power than the alpha rays, and the beta rays, which are emitted with a velocity of 1% to 99% of velocity of light, and the mass of beta particle is found to be 9.1 into 10 to the power of minus 31 kg, and charge is found to be 1.6 into 10 to the power of minus 19 coulomb. Hence, these particles are identified as an electrons. Already we know mass of electron is 9.1 into 10 to the power of minus 31 kg, and the charge of electron is 1.6 into 10 to the power of minus 19 coulomb, so which is same as the beta particle. Therefore, it is a negatively charged one, as well as we can call it as it is identified as electron. Coming towards the next, that is the last one, is the gamma ray. The first one, the property of gamma rays. Gamma rays, they are not at all deflected by electric and the magnetic fields, hence the gamma rays are uncharged one. Similarly, second one, the ionizing power is very low as compared to that of the alpha as well as the beta rays, but the penetrating power is very high. The gamma rays have very high penetrating power. The penetrating power is 100 times more than that of the beta rays. Similarly, gamma rays are found to be electromagnetic waves which are traveling with the same speed of light, that is 3 into 10 to the power of 8 meter per second in vacuum. And gamma rays, they can destroy the living tissue, and this property is used in the treatment of cancer. Similarly, gamma rays produce photoelectric effect and the Compton effect when incident on the certain substance. So, these are the properties of alpha as well as beta and the gamma rays. So, just go through the video. Thank you.